Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 3 Learning Target 6. Today we're going to talk about factoring without a B term. When that middle term is missing, what do we do? How do we factor expressions like that? So if there is no B term, let's just think back. Our standard form of a quadratic looks like this. So we're talking about these quadratic expressions. The standard form of a quadratic expression looks like this: ax squared plus bx plus c, where the a term is always with the x squared, the b term is always with the x to the first, and the c term is always the constant, okay? Now, today, we're going to talk about what happens when this term is missing. What happens if we just have ax squared plus c? What do we do with that? Because how do we set up an x with that? How do we go through the reverse box method if we're missing that middle term, if there's no middle term? Well, what we're going to do is we're going to fill in a placeholder for nothing. Our placeholder for nothing in math is a 0. So we're going to put a 0x in for that b term when we don't have it, because we all know that 0 doesn't carry any weight. 0 is our placeholder for nothing in math. When we have something that doesn't carry any weight, we use a 0. We also know that if we have 0 times x, that 0 times x is going to fall to 0, which still doesn't carry any weight. So we don't alter the original expression by filling in a 0x in the middle, and now we've got something to put in the bottom of our factor x. This pattern right here is called a difference of squares. You're going to see a difference of squares when we're looking through all of these expressions here. And you're going to start to see a pattern in how they get factored out. So let's just take a look at a few. The first one, we see x squared minus 9. So what you'll recognize is you've got the ax squared term and you've got the c term. But the b term is missing. That one is the one that's not there. So when we rewrite this, we can rewrite this as x squared plus 0x minus 9. So that 0x is that placeholder for us, and now we can go ahead and factor this. So here's what happens when we set up our factor x. We've got 1 times negative 9, which is negative 9, and now in the middle, we have a 0. So the question becomes, what gives us a product of negative 9, but a sum of 0 at the same time? And it's weird, but something does actually exist. What happens here is I need 3 and negative 3. 3 times negative 3 is negative 9. 3 minus 3 is 0. So I split apart that 0. It gives me x squared plus 3x minus 3x minus 9. And then I can put those terms into my reverse box. X squared, 3x, negative 3x, and negative 9. Find your factors, your GCFs from there. The first row has a common factor of x. The bottom row has a common factor of negative 3. Notice that both of them are negative, so I need to take a negative out of it. The first column has a common factor of x, and the second column has a common factor of positive 3. So the factored expression, the factored form here looks like x minus 3 and x plus 3. So check that out, okay? Let's take a look at number 2. So in number 2, I have x squared minus 49. And again, I've got the a term and I've got the c term, but the b term is not there. So if I rewrote this, it would look like x squared plus 0x minus 49. And then I can go ahead and factor. When I factor, I've got negative 49 on the top and 0 on the bottom. So what gives me a product of negative 49 but a sum of 0? And that would be 7 and negative 7. So I've got 7 and negative 7 here. That's what splits off my middle term. X squared plus 7x minus 7x minus 49. And then I throw those in the box. I end up with x squared, 7x, negative 7x, and negative 49. Here's the like terms that I can take out. The first row has a like term of x. The second row has a like term of negative 7. The first column has a like term of x, and the second column has a like term of positive 7. So my factors end up looking like x minus 7 and x plus 7. Are you starting to see a pattern yet? Okay, let's move on. Let's look at a few more. In the next one, I've got 2x squared minus 8. So 2x squared minus 8. The first thing that I recognize, well, two things. I recognize two things right away. The absolute first thing I recognize is the fact that the b term is missing. So I need to fill that in. However, I also notice that these two things have a common factor of 2. So I'm going to take that GCF out because that's going to be important when I go ahead and factor. I have to pull the GCF out first. So when I pull the GCF out, I get 2 times the quantity x squared minus 4. Okay, that really is x squared plus 0x minus 4 because of that missing middle term. So again, you can fill that middle term in with a 0x. Don't forget that this 2 is part of your answer. It's going to be on your factored form at the end. But now we're just going to factor this trinomial. So I've got a product of negative 4 and a sum of 0. Product of negative 4 and sum of 0 is 2 and negative 2. So when I split that, it looks like x squared plus 2x minus 2x minus 4. So in my box, well, I didn't leave myself a whole lot of room. Sorry, I'm going to write small here. X squared, 2x, negative 2x, and negative 4. So x squared and 2x, I get a common factor of x. The bottom row, I have a common factor of negative 2. The first column, I have a common factor of x. And the second column, I have a common factor of positive 2. So I end up with x minus 2 and x plus 2. But then I have this guy from the beginning that I took out. 2 times the quantity x minus 2 times the quantity x plus 2. Let's take a look at number 4. Again, I recognize that there's a GCF in there. Again, I also recognize that my 0x in the middle is missing. So I'm going to take out a GCF of 3. So 3 comes out front, and that leaves me with x squared minus 1. But again, I'm going to make that 3 times x squared plus 0x minus 1. And this piece is going to get factored. So I factor that. I have a product of negative 1 and a sum of 0. That's going to be 1 and negative 1. So that really, this middle trinomial is actually x squared plus 1x minus 1x minus 1. And those things are going to go inside the box. Don't forget that this guy is part of your answer at the end. So inside the box, I have x squared, 1x, negative 1x, and negative 1. My first row has a GCF of x. Second row has a GCF of negative 1. First column has a GCF of x. Second column has a GCF of positive 1. That's x minus 1, x plus 1. GCF that I took out at the beginning was a 3. There's my factored form. If you haven't noticed this pattern yet, I want you to take a look here. We're going to just pause for a second. Ignoring the GCF out front, come back to number 3 and take a look at your factors. X minus 2 and x plus 2. Take a look at what we had in our factor x here. 2 and negative 2. Over here in number 4, x minus 1 and x plus 1. Take a look at our factors. 1 and negative 1. The other thing I want you to take note of is the 4, the 1, all of those C terms, okay? What do you notice about the C terms? There's something special about them, okay? The C terms that we've had so far have been, we had a 49, we had a 9, we had a 4, and we had a 1. All of these things are what we call perfect squares. Those perfect squares are what give us the phrase difference of squares. That's what these trinomials are called, difference of squares. It's a difference because we are subtracting in all of them, and it's a difference of squares because you end up with a perfect square in your C term. The only way to get 9, or not the only way, but one of the ways to get 9 is to multiply 3 times 3. In 9's case, it is the only way. That's not always true. But with perfect squares, what it means is you can take an integer and multiply it by itself to get that number, 3 times 3. But now if you want one of those to be negative, that's going to give you a negative 9. So 3 times negative 3 gives me negative 9. 7 times negative 7 gave me negative 7. 2 times negative 2 gave me negative 4. 1 times negative 1 gave me negative 1. That's what gets me to the middle terms canceling out, because 2 minus 2 is that 0. So your b term goes away. And that also gives you the same two factors, but one is positive and one is negative. X minus 1, x plus 1. So that's kind of a pattern here, and you can start to recognize those patterns, and they can help you speed up your factoring process. Okay, so we're just going to do some more practice with general factoring from this point on. We've done a few with the difference of squares, but now we're just going to go back to some regular old factoring just to get a few more examples in. So take a look at number 5. There's no GCF here. I have a middle term. I'm just going to straight up factor this trinomial. 1 times negative 21 is negative 21. Middle term, negative 4. What gives me a product of negative 21 and a sum of negative 4? That would be negative 7 and positive 3. So that's what my 4x gets split into in the middle. X squared minus 7x plus 3x minus 21. Then I throw those things in the box. I always make my box kind of small. Hopefully you made your box with enough room. 3x, negative 21. And find those GCFs. When I look for the GCFs, the GCF of the first row is going to be an x. GCF of the second row is going to be a 3. The GCF of the first column is also an x, and the GCF of the second column is a negative 7. So my factors that I end up with here are x plus 3 and x minus 7. Some of you may have also noticed that these things right here are the same thing as these things right here. That's another little trick that you can learn about factoring. However, this is a trick that only works when a is equal to 1. Okay, so that a term right here, my a is equal to 1. So what happened here is, since my a is equal to 1, whatever I get as my factor solutions, I can just drop those into my factored form. And that's the factored form of that expression. But again, it only works when a is equal to 1. So like in number 6, that theory is not going to work. Okay, so let's take a look at why. So in number 6, I have 3x squared plus 2x minus 5. There's no GCF here. So there's no GCF I have to take out. This is a standard trinomial. I have a b term. When I set up my factor x, 3 times negative 5 is negative 15. Middle term is 2. So a product of negative 15 and a sum of 2 would look like 5 and negative 3. All right. So when I split that middle term, I get 3x squared plus 5x minus 3x minus 5. Okay. Now, some of you may think, can't I just write these out as x plus 5 and x minus 3? Because whatever I get should match this? Well, that is not the case here. Because if you think of multiplying this back together, x times x gives you x squared, but you're missing the 3. That's why it doesn't work when your a is not equal to 1. My a isn't 1 here, so these can't just be my factors. I have to go through the process of doing the reverse box to figure out what the rest of the factors are. So I have 3x squared, 5x, negative 3x, and negative 5. So then my GCFs here, 3x squared and 5x, I get an x. Negative 3x and negative 5, I get a negative 1. There's nothing that comes out of the 3 and the 5, but they are both negative. So I'm going to take the negative out and call it negative 1. The 3x squared and 3x, I can take out of 3x. And 5x and negative 5, I can take out of 5. So my factors look like x minus 1 and 3x plus 5. Which, by the way, these things are not the same as those things. I've got a 5 and a negative 3. Here I've got a negative 1 and a 5, but but the 3 is in front of this x. So it's a little bit different. When your a term is not equal to 1, you have to go through this reverse box method. Let's try 2 more. I've got x squared minus 7x minus 18. Again, there's no GCF. Again, I've got a b term, so this is just straight up normal x factoring. I have 1 times negative 18, which is negative 18. Middle term is negative 7. This is one where a is equal to 1, so yay. We can take a little shortcut here, and I'll show you what that shortcut looks like. So negative 18 and negative 7, that means product of negative 18, sum of negative 7, that's negative 9 and positive 2. Negative 9 times 2 is negative 18. Negative 9 plus 2 is negative 7. So here's your shortcut. Are you ready for this? This is going to be mind-blowing for you. Since my a term is 1, my factors are x minus 9 and x plus 2. Boom. Done. I can skip the reverse box. However, once again, I want to warn you, that only works when a is equal to 1. So I've got x minus 9, x minus x plus 2. Those are my factors. That's my factored form, and I'm done. I skipped the whole reverse box method because I found those. Yay. Let's take a look at number 8. This is our last one for today. So now in this one, I've got 4x squared plus 21x plus 5. Now you might be asking yourself, can I use the shortcut here? And your answer is no, you cannot. A is not equal to 1, so that means no shortcut. So be careful with that. You have to go through the reverse box method here. Now, one thing you can recognize is there's no GCF, and I have a middle term, so this is really just standard factoring with no GCF involved. 4 times 5 is 20, middle term is 21, product of 20 and sum of 21, that's going to give me 20 and 1. So split those apart. 4x squared plus 20x plus 1x plus the 5 from the end. Throw them in a box because I can't use the shortcut here. That's 4x squared, 20x, 1x, and 5, and find those GCFs. So 4x squared and 20x, I can take out a 4 and an x. 1x and 5, I can take out a 1. 4x and 1x, I can take out an x, and then 20x and 5, I can take out a 5. So my factors look like 4x plus 1 and x plus 5. And again, I want to point out the fact that the things you ended up with in your factored form are not the same as what you had when you solved the factor x. So we had to go through this middle step of the reverse box just to get, just to get to that factored form. All right, so thanks for tuning in today. That's the end of our lesson for now, and I will catch you next time.